Hello, in this video we are going to talk about a generic view on embedded system. So I would like to give you the generic perspective from the upper point, and then we will go into the specific parts. So where to begin? This is an NXP board, NXP IMX 8 something. This board used as a reference point for the projects to be developed in the embedded system domain. In general, for the high-level OS, we have these vendors. What vendors do we have? We have NXP, we have Qualcomm, we have Asus recently, and Intel, for example. We have many others. We have Texas Instruments, which is also important. So these vendors develop these reference platforms. So in the reference platform, they use their latest SoC. So here is the SoC, and their purpose in making these reference platforms is to sell their SoCs. And they are giving these reference platforms to the hardware and software companies so that they can customize it, as we discussed in the last lecture, so that the software company and hardware company will customize the hardware and the software, whatever we will be delivered. So first we will be delivered the hardware itself, and the second is we will be delivered a reference software. We can call this BSP, Board Support Package. This will involve the Linux or Android source. So as I said, the hardware company will customize the board and get rid of the unused peripherals and unused features. And accordingly, since this new board is a customized board, the software, the reference software, should also be customized. So let's say we have here Android, then we have here a custom Android. And that is what we want to do as embedded Android developers. So we want to take some reference software, referent Android BSP, let's say Android 12, then we would like to turn this into custom Android 12 that can run on the custom board. So this is the idea. Here we can go into a bit more in detail. What is our purpose as embedded software engineers working for high-level operating systems? So we have our development board here. A development board, or a, let's say, target platform, is similar to a computer. So with what we have in a computer is, first we have a CPU that is responsible for processing. The second is we have a non-volatile memory, which is called a storage. Storage can be some sort of a flash or an SD card, or even in PCs some SSD disks. So the goal of the storage is to retain the data even if the electrical power is lost, and to retain the information across reboots. We have also what is called a random access memory, RAM. This is in comparison to the storage really high speed. Therefore, during runtime, RAM is utilized since it's high speed. But the downside here for the RAM is that it doesn't retain any information when the electrical power is lost. Therefore, we need both. We need for the runtime, we need for a fast access, we need a high speed memory that can communicate with the processing unit, of course, and in order to retain the data, we need a storage. We have also something called a boot ROM. ROM means read-only memory. ROM is typically a really small storage that acts similar to a storage, let's say, but it is usually used for booting the CPU. So once we turn the power on, let's say, the CPU, the first instructions will be loaded from the boot ROM. It will be used for booting the system. And we have additional chips. So this can be many additional chips. We can give the example of Wi-Fi modules. We can give Bluetooth modules and many more. And the point here is we have some units, some hardware units that require some software to run. So let's point these out. So we need software to be provided for the CPU for it to run, and we need software to be provided for the additional chips, and we need software for the ROM. Of course, since we cannot store anything here, we will use the storage for storing information. So all in all, we have a CPU, a memory, storage, and some chips, and we need to store information, software, on those in order for this board to boot properly, because we are targeting to either boot Linux or Android here. So let me denote. So we need software and storage, boot ROM, and additional chips. Okay. In the development PC, in order to generate the images that are required for this target platform to run, we have some source codes. So first, we have the Linux and Android source code here. And the second, we have the bootloader source code. The third and fourth is that we have the firmware for the boot ROM and the additional chip firmware. So these two are directly firmware, so we only need to flash these to the appropriate chip. We don't need to generate anything else, do anything else. But for the case of the Linux or Android, we will be generating some images. So from the Linux and Android source code, what we will get is we will first get kernel image, and the second is we will get a root file system image. From the bootloader source code, if we feed this into the build system that we will be using, we will get a bootloader image. And of course, we can feed these already prepared, firmware binaries to the build system, and these will be ready at the end for deploying. We have some source codes, some firmware, and we have access to a what's called a build system. And build system is able to compile code and generate images to be flashed to the development board. And for the compilation itself, build system references to and uses toolchain. Typically, this is GCC toolchain for the Linux and Android environment. This you can think of as a basically compiler. Yeah, and as I said, for the source codes, the toolchain will be used and the images will be outputted, and the configuration files and firmwares will be also put to the output of the build system. You can see what I described beautifully, let's say, visualized. So from Linux and Android source code, we have the rootfs image and the kernel image. We have the bootloader source, we have the bootloader image, and we have the additional firmwares. And the purpose here, as I told you, is to flash the hardware units that require software with these images so that the target platform can run Linux or Android. So what we'll be doing in the flashing procedure is we will be putting the rootfs image in the storage. We will also be putting kernel and bootloader images in the storage. And we will be flashing our boot ROM with the firmware that we have available, and any additional chip firmware we will be flashing as well. So what we do as creators of custom software, we tailor the Linux and Android source code, and we tailor the bootloader source code. So we trim any unnecessary parts. We put our code in there. We develop new features, and at the end we can obtain some root file system that is custom, some kernel that is custom, and some bootloader that is custom that we can put in the storage. And additionally, of course, if we have the source code available for this additional chips and boot ROM, we can also customize them, but usually these are the source code for these are not available, so we will be directly flashing these. And then we will make sure that our embedded system is running Android and Linux.